Hi everyone. Before start explaining Kubernetes architecture, let's go back and understand why Kubernetes and why we switched to Kubernetes, why where people are moving to Kubernetes instead of VMware or legacy systems concept. Why we are moving to Kubernetes? For example, if you see this traditional deployment model, if you want to deploy any application on any of the hardware, we have to prepare the hardware setup first. On top of that, there will be a operating system. On top of that, we'll be creating a services manually, means like install the applications, say binary executable files, everything. And once after that we evolved and will be a hypervisor box. On top of that there will be a hypervisor will be running, and top of that we'll create a individual virtual box instead of creating a individual VM like a individual box. We'll create a virtual machine on top of the single operating system. So for that, on top of that there will be a guest operating system. On top of that we used to install the applications, and then we slowly yeah, now the containerization deployment will be running yeah, everything as a containers. Now there will be a single operating system, and on top of that the container runtime Docker or container D will be running. On top of that our applications will be running. Okay. Now, what is Kubernetes? Kubernetes is a portable and extensible open source platform for managing containerized workload service that facilitate both the declarative configuration and automation. And why we need a Kubernetes? Container is a good way to bundle and run your application. And Kubernetes provide you with a framework to run distributed system resiliently, and it take care of scaling failover of your application and provides a deployment pattern. These are all the main useful mechanism. Previously, if you want to scale up your application, you have to create all the VMs and install manually all the deployments. Then you have to attach to the load balancer those VMs. So many work right now. Comes to Kubernetes, the scaling and self-healing and storage orchestration and service discovery, load balancing. Uh, and horizontal scaling. These are all the main Kubernetes feature which will help developers or application resiliency and availability to make sure the application scale whenever the traffics increase. These are all the main useful in the Kubernetes if you use. And come to cluster architecture. Mainly there will be a control plane instance, and there will be a worker nodes. And on in the control plane, if you are managing your self-hosted Kubernetes, then you have to take care about this control plane. And these are all the main component comes to control plane. The Kube API server is a component of the Kubernetes control plane that expose the Kubernetes API. This is the main communication channel between all your nodes and the control plane. And once the request comes from the node, that will in turn it will talk to other services, and it will work on the based on the request. Similarly, etcd is also part of the control plane component, and consists of highly available key value store used in Kubernetes. It mainly uses the state to store the entire state in the etcd. And kube scheduler will be the responsible for assigning the pod to node and manage service. We have a Kubernetes cluster provided by the public clouds like AWS EKS available, and Azure we have AKS, and Google Cloud we have GCP, uh, GKA clusters. Come to these kind of managed service cluster, we don't need to manage those control plane is taken care from by the cloud provider. We have to mainly work on only worker nodes and set up based on our the requirement node configuration. We have to do it. Nodes actually there will be two service running, kubelet and kube proxy. Kubelet is mainly communicate with the kube API server, and kube proxy will distribute the traffic between these deployed pod. And one more component, the Docker container D will be also running in the node level. Yeah, thank you. Please do let me know if you have any questions.